do have a strategy, a very strong strategy and a very strong push to enable that strategy. We are focused 100% on the crystalline silicon market, and our goal is to enable our customers' roadmaps, to accelerate our customers' roadmaps. And so what do I mean by that? As we've gone around and discussed roadmaps with customers, tier one customers mainly, we've found that there's this underlying drive, this underlying treadmill, this clock, I'll call it, that our customers are driven to improve their module power output or their cell output about 10 watts every year, every single year. And as you know, for the last 20 plus years in the solar industry, we've basically had one cell design, a standard cell design. Well, it's as we thought, approaching its entitlement. It's getting harder and harder to get those gains, but the demand for those gains is not getting less and less. So I think we've found a technology inflection, or the need for a technology inflection, and we validated it with our tier one customers. So enabling this technology clock, this 10 watt per year improvement, is the foundation of our strategy. And every one of our products, we have products that are in 5 different segments in the crystalline silicon market. We have screen printers, obviously, we have wire saws, we have ion implanters in the doping segment, we have a new passivation tool coming out for the passivation segment, and we have wafer inspection metrology tool. All of these tools are geared to support that strategy in 4 areas. One is improved performance, no question. Cell efficiency, module power has to improve year over year. The second is to lower cost. As you've seen, the ASPs dropping down in the industry, our customers feel a distinct pressure to have to reduce cost year over year. So the performance has to increase, the cost per watt and the cost per wafer has to come down. In manufacturing, these processes have to be scalable. So the yield has to improve, the number of steps has to decrease, the distribution of their output of their lines has to improve, because all of that is tied directly to profitability. Most of these guys are right on the edge of profitability now. The move to these advanced cells, we think, will put them over the edge of that. And then the final piece is extendable. If you invest in a product today, you want it to exist for multiple generations of your product. This goes back a little bit to the semiconductor. A product introduced at one node can serve multiple nodes. Your investment is leveraged over multiple nodes. It reduces your R&D investment over the long term, and you get more benefit, more ROI, so to speak, out of that tool. So if you look at the multi-market today, the efficiency, you're correct, has improved from 16.5% on average up to 17.5% on average over the last 2 years. On the mono segment, efficiencies have improved from 18.5 to 19.5 in the last 2 years. Now those have all been with small incremental gains done basically through materials improvements, substrate improvements, and the thought process is, and it's been confirmed by customers, is that it's getting harder and harder to make those kinds of gains. They're necessary, they need them every year to improve profitability, but it's getting harder and harder to squeeze more out of those type of cell designs. So what we need to do is start to introduce what we'll call the second generation cells, rear passivated cells, cells that are rear contacting, either MWT or IBC type cells, the use of implantation for both P and for N type cells. All of that both improves the performance, cell efficiency and module power output, but the gains are significant enough that the dollar per watt actually comes down over time. So those are the types of things I'm talking about. So yes, will there be an acceleration? Yes, we would like to see multi-efficiencies up in the mid 18% range in the next year, mono efficiencies up over 20%, and then the roadmap to 21, 22% and beyond. There is still a gap between capacity and installed demand. We see the end market continuing to grow, actually with strong growth, 15% per year growth. We see it somewhere around 35 gigawatts and growing close to 40 gigawatts. But if you look at the install base, just looking at our own tools, there's probably about 60 gigawatts of capacity out there today. Now the real question is how much of that capacity is going to be efficient and effective for the next generation cells. And again, this goes back to our strategy. If we can drive a technology inflection that maybe obsoletes some of the existing capacity while at the same time improves our customers' profitability, that's a win-win for both of us. I call it the virtuous cycle. If our customers are able to improve performance, consumers want that performance and will pay for it. Our customers become profitable, they reinvest to continue that performance gain. And so that's what we'd like to start here. It's all going to start with us driving the technology to the next generation. If we remain where we are today, as stagnant at where we are today, then you will have this gap in supply and demand probably for the next 2 years. Our job is to try and accelerate that and obsolete some of the existing capacity by replacing with new equipment. And then the value of the equipment has to be enough to where our customers are willing to invest what little profit they have into capital investments for this equipment. We're very aware of that and very focused on proving that value to our customers. Certainly in mid-next year, we should be in full technology buys. Right? This is similar to semi-buying, where as you're developing the next generation, the technology buys precede the capacity buys by 6 months to a year, depending on the complexity. So certainly next year we expect to see some technology buys for our new equipment. And then sometime probably in the second half of 15, about a year later after the technology buys, we expect to see that those tier 1 customers will start ramping those advanced cells in production, and that's when we'll start to see capacity buys. For any sort of inflection, there has to be a driver. In semi, it's Moore's law. And for it to be a real driver, there has to be something in it for the manufacturers. They have to be able to make money doing it, otherwise it's not going to make economic sense. So, as I mentioned at the beginning, the efficiency clock is effectively reinforced by the Chinese policy that says you need to have, if you're going to open a new fab, you have to be at a minimum of 18% for multi and 20% for mono. That's sort of saying you can't just start over where you left off because we may not get out of this situation if that happens. You need to move to a next generation technology. You need to find ways to innovate. Now, obviously, what goes along with that is you have to invest in order to do that. So you're right. I think the tier 1 guys are coming back to profitability. I think they'll be there within the next couple of quarters. There will be some availability of funding to look at new generation technology to invest, and then government policy along with this industry efficiency clock and economics of staying on that clock will push the tier 1 guys certainly in that direction, and we'll see them invest, and they will increase their R&D spending. And then again, if the cycle works and you see the benefit of the R&D investment in terms of profitability in the future, the cycle will continue. Right? We're not going to wait. Right? We need to make it happen. So we're going to do everything we can this year, certainly with the tier 1 partners, to drive the adoption of new technology, and then the ramp of that into capacity in 2015.